Okay, thank you. Thanks for having me. This last talk will be about security, token-based security to be more precise, and I've prepared several things for you. First of all, I want to show you the state of the art of token-based security. Then we will talk to issues that leads to new best practices. Something changed in the last year, and so it is quite interesting to look into it. I will also show the proposed solution provided by those new best practices. We will talk about token refresh and HTTP-only cookies. But first of all, let me introduce myself. I am Manfred. I'm a trainer and consultant for Angular. I'm helping a lot of companies. I'm part of the Google Developer Expert team, and since the beginning of this year, I'm also part of the Angular team. And my current product is a workshop about Angular in the enterprise. So let's get started with the state of the art of token-based security. So perhaps you might know this. When using token-based security, everything starts with the client redirecting the user to the authorization server. And there, the user logs in, for instance, with a password, or with Windows security, or with something else. After that, the user is redirected to the client, and so the client gets an access token. And by means of this access token, the client can access the backend on behalf of the current user. This is what token-based security is about. And this brings a lot of advantages. For instance, you can use one central user account. That means you have one user account within, let's say, Active Directory or a cloud solution or something else. And you can use this one user account with a lot clients and with a huge amount of backend services. Only the authorization server sees the password. This is also an advantage. You are redirected to the authorization server to type in your password. You don't have to tell this and that and those clients your secret password. The authentication is decoupled from the client, which means you can sell your product and the customers can use it with all the existing identity solutions out there. Some of them might use Active Directory, some of them might use a cloud solution, some of them might use an IBM-based solution, which is very expensive, but just doing the same. Also, tokens provide flexibility. One resource server can forward the token to another resource server, and so every instance in this chain knows who the user is. Also, you don't need cookies anymore, and so you can't get the victim of things like cross-site request forgery attacks. To implement this game, it is very common to use standards like OAuth 2 and OpenId Connect. They are standard nowadays, and when we look at those two standards, they provide something that's called the implicit flow. Perhaps you've seen it. The implicit flow works like this high-level perspective I've shown you before. The user is redirected to the authorization server. When the user comes back, the client gets a token. To be more precise, it gets two tokens, one access token and an identity token. The access token is for the client, so that the client can find out who the user is. And the access token is intended for the resource server. It gives the client access to the resource server on behalf of the user. Saying this, the identity token is normally a JSON web token, which is just a bunch of JSON with a signature. It can be encrypted. And this makes sure that the JavaScript client can parse and read it, that it can find out who the user is. This is the current approach. And unfortunately, this approach has some issues. There are some drawbacks here. There is a new best practice document. The latest version has been created in summer this year. And this new best practices document advises against implicit flow. It says, hey, what we have done in the last 6 years is not secure. Don't do it, because there are some possible attacks on implicit flow. And to be honest, this is everything but new for us. We all knew about these attacks since Angular and OAuth 2 has been out there. There is even a document, a threat model document from Jan 2013. This was released some months after OAuth 2 was released, and it lists all those possible attacks. Saying this, you could now think, have we been naive for the last 6 years? And the answer is, of course, no. We have not been naive, because we know all those attacks and we implemented good solutions which are preventing those attacks. Nearly each and every serious implementation of OAuth 2 and OpenID Connect deals with those attacks somehow. So it is not that a big deal. Also, OpenID Connect enforces some of those best practices to prevent attacks. Let me just show 2 of those attacks that are possible with implicit flow when you don't align with best practices. The first attack is about an attacker which sends you an access token and an identity token. It gives you an URL, and this URL contains his very own access token and his very own identity token. And what do? You click on the link, the application comes up, and you are authenticated as this attacker. Perhaps you don't know it, and so you type in sensitive data, your credit card number or something like this. What you don't know is that when you save it, it will be saved for the attacker, and afterwards he or she can read your sensitive data. This is one attack. Another attack is about having those access tokens and identity tokens as part of your URL. If it is part of the URL because of the redirect, it will be locked within the browser history, and it will be locked within server-side logs. That means the attacker just needs to get access to something that is not that trustworthy, namely server-side logs, and so they can find out your access token. And also, this is not a big deal because you can configure the logging behavior of your server and you can rewrite the browser history. The thing is, you just have to think about it. That means you just need a line to a whole list of best practices and you should be on the safe side. Well, this current best practices document provides another solution. It says, please use another flow that does not need this long list with best practices to prevent all those attacks. And this flow is called Codeflow. Perhaps you've seen it before. Codeflow was intended not for single-page applications. It was intended for server-side applications, and it was used for native applications, native Android applications or native iOS applications. But now it's also a thing for us, for single-page applications. At first sight, it looks like implicit flow. You are redirected to the authorization server, and now you don't get an access token back, you don't get an identity token back, you get a code back, a one-time code. It can only be used once. And now with this code, you are approaching the server again, and you exchange this code by the access token and by the identity token. Well, perhaps you're wondering why this is safer. And the answer is, it is safer because the token is a one-time token and because the code here is exchanged via an AJAX call. Point 3 here on the slide is an AJAX call. It is not a redirection. We are directly calling the server using HTTPS via an encrypted channel, and that means we can also verify if the backhand is the right backhand or some attacker who gives us the wrong token. The thing is, you could say now this code can be stolen. Of course, the code can be stolen, but there is another protection that prevents that when someone is stealing it, he or she can use it in a proper way. And this extension is called Pixie. It's quite a nice name if you ask me. Pixie, P-K-C-E. It stands for Proof Key for Code Exchange. And the implementation is quite simple. First of all, the client is creating a random string. Just a big random string. And the client is saving it somewhere, perhaps within local storage. And then the client is redirecting the user to the authorization server with a hash value of this verifier. Not the verifier itself, just the hash value. And for the first step here, the server is just storing this hash value in some database. Then the authorization server sends back the code, and then the client tries to exchange the code for an access token and for an identity token. And when doing so, it sends over the full verifier. That means now the authorization server just compares the full verifier with the hash code it received before. And if they fit together, the authorization server knows, okay, this is the right client. This is the right client, which is allowed to use this code to get back an access token and an identity token. So quite smart. Those things have been around for several years and heavily been used with native applications like iOS or Android. Well, there is another attack. This bad guy here could say, hey, I'm stealing your tokens after you've received it. I'm stealing it by using cross-site scripting. And also for this, there are some solutions out there. For instance, you could heavily use frameworks. Angular, React, or Vue are doing really a great job when it comes to preventing cross-site scripting. They are decoding everything by default. Also, you could look into content security policy, which is a browser feature which tries to minimize the surface for such attacks. And this is a best practice in the world of OAuth 2, you should work with short-living tokens. It is very common that such a token does not live for a whole day, for 8 or 10 hours, no. Normally, it just lives for 10 minutes, plus minus. Because if the attacker gets it, he or she cannot use it for quite a long time, just for the rest of the 10 minutes. The tinier this time slice is, the more safe you will be. So that also means we need to refresh our tokens to get new tokens, because the user does not want to log in on a regular basis each and every 10 minutes. And this leads us to the topic of token refresh. Token refresh means that you can get a refresh token alongside all the other tokens. This refresh token is stored within the browser, and after, let's say, 10 minutes, or perhaps after 8 minutes, to have some slack, you are sending to the server this refresh token again to get a new access token, a new identity token, and a new refresh token. Perhaps you're wondering why this refresh token is more safe than an access token, because it can be stolen anyway. Well, it is more safe because it should be a one-time token. It is only allowed to use it one time. And it is also more safe because it is only sent once over the wire, namely if we need a new token. It is not sent time and again over the wire like the access token. It is just sent once back to the authorization server, namely when we need a new access token. So it sounds quite simple, but to be honest, it is forbidden for browser applications. At least it was forbidden for browser applications because, as I've told you before, within a browser, everyone can steal a token by means of cross-site scripting. This is quite a pity, because this demanded us to do a lot of nasty workarounds. But the current best practices document says it is allowed to be used if you take care about several things. For instance, you need to know the threats, and you have to take care of them. You have to take care of cross-site scripting. This is the precondition. Then the refresh token needs to be a one-time token. This is not something the standard prescribes, but now if you want to align with the current best practices document, this needs to be a one-time token. And if two people are using the same refresh token, you have to lock both of them out, because one of them will very likely be an attacker. You cannot tell who of them will be the attacker. You don't know if the attacker was faster or the user was faster. And to be on the safe side, both of them need to be thrown out of the application. Okay. By the way, if you are into Angular and if you look for an implementation that can do this, then check out this library here, Angular OAuth 2 OpenId Connect. It is written by quite an ugly guy, by me. And it is not bad even though, because you see, I have a lot of downloads and I'm OpenID Connect certified, so you should be safe with this. Saying this best practices document proposes another thing, which seems to be a contradiction in itself. It proposes to use HTTP-only cookies, because the safest way to store a token within the browser is using HTTP-only cookies. And in this scenario, the client would just talk to the resource server, and it will assign a cookie so that it can remember the user. And everything else happens behind this resource server. That means that the resource server is doing the OAuth dance and the OpenID Connect dance to get an access token. And also, you need to use cross-site request forgery tokens to avoid those attacks basing upon cookies. This is one drawback of this system. Another drawback is that the resource server needs to be aware of the web client. That means you don't have a simple RESTful API anymore. You have more. You have a full web solution on the backend. You have a backend for your frontend, which is aware of your client, which is aware of using cookies, which is storing the access token on the server side for you. Also, if you need to delegate to another resource server, then you have to tunnel this request through your backend, because you have the same origin policy for cookies here. So, as you see, this operation mode is more safe because of HTTP-only cookies. JavaScript cannot steal these cookies because JavaScript is not allowed to reach HTTP-only cookies. But on the other side, it is quite inconvenient. Might be the right solution if you just have one and only one backend. So let me sum up. We have seen that implicit flow is okay. If you are using it, don't panic. It is okay as long as you are aligning with current best practices. But for new solutions, I want to encourage you to use Codeflow and Pixie, because this is now the suggested approach. We have seen refresh tokens are allowed now under several circumstances. You have to make sure that you prevent cross-site scripting and all the other stuff. And we have seen that using HTTP-only cookies is the most safe approach, but it is also quite inconvenient. Perhaps it fits to your solution, perhaps it does not. Okay, so I say thanks for having me. Here you have my contact data. You will find also my material on my blog, and have a nice day. Thank you.
Thank you, Manfred.